In this lesson, I'm going to be talking about how to factorise quadratics. Now, by factorising, we mean putting it back into brackets. So it helps if you've first got a good idea of how to expand double brackets or expand quadratics. By a quadratic, we just mean an expression that could have any coefficients, but the highest power of the variable is 2. So in this example, our variable is x, and our highest one is x squared. We've also got an x term and a constant. Even if one of these terms was not there, so if we didn't have an x term, that would still be a quadratic. So we're going to be talking about how to put an equation with an x squared in it back into brackets. If you've looked at the video on expanding brackets, then you know that we will need two sets of brackets. And it helps if we first think about how to expand them. This will help us go the other way and factorise them. So to start with, let's expand this double brackets. And you might have a different method for doing it. You might do it using the FOIL method, or the smiley face, or the claw, or the grid method. But all this really means is that everything in the first bracket has to be multiplied by everything in the second bracket. So we've got x times x, which gives us x squared, and the x also has to be times by the minus 2, so minus 2x. We've then got the 3 times the x, which gives us plus 3x, and the 3 times the minus 2 to give us minus 6. We've got 4 terms, and you should always end up with 4 terms if you've got two brackets multiplied together, each with 2 terms in. But we can then simplify the middle two terms together. So minus 2x plus 3x is just 1x, and we've still got the minus 6. So x plus 3 times x minus 2 gives us x squared plus x minus 6. If we think about what this means that if we take the quadratic equation x squared plus x minus 6, x plus 3 and x minus 2 are both factors. So they are two things that multiply together to give us the equation x squared plus x minus 6. So that's what we mean when we're factorising something. We are trying to find the factors. So just like if you want the factors of 6, that would be 2 and 3, because 2 times 3 is 6. Here the two brackets are each a factor, because you multiply them together to get your x squared plus x minus 6. Now, to think about factorising, my preferred method is using the grid method. So if we just look at how that works for multiplication first, for multiplying out the brackets, we can see how it could then help us to go the other way. So we've got x plus 3 multiplied by x minus 2. And this grid allows us to multiply everything in the first term by everything in the second term. So this is a multiplication grid, which means that we need to multiply everything. So x times x for the top left box gives us x squared, plus 3 times by x is 3 lots of x, minus 2 times x is minus 2x, and plus 3 times minus 2 is minus 6. Now you can see that this is just the same as what we did up here, but it will help us when going the other way. We can then add up all our terms. We've got the x squared, we've got the minus 2x and the plus 3x here to give us plus 1x, and then the minus 6. So if we just think of another example to see how it's working. So if we want to multiply out x plus 4 times x plus 2, we can draw ourselves a grid. We've got x plus 4 times x plus 2, and again it is a multiplication grid. So x times x is x squared, plus 4 times x is 4x, plus 2 times x is 2x, and plus 4 times plus 2 is 8. So we can then simplify it by adding these two terms together. So we've got our x squared in our top left, the plus 2x and plus 4x give us plus 6x, and then we've got the 8. Now if we compare the two grids, we can see that in both cases we end up with an x squared in the top left. That's always going to happen. It might be more than one x squared, but it will always be our x squared term, because that's the only square in the grid that has an x term times by an x term. In the bottom right hand of the grid, we end up with just a constant. And again, that's always going to happen because that's the only square that has a constant times by a constant. The other two terms are both x terms, and they combine together to give us our x term. So in both cases, those two boxes, because it's an x times a constant term in both of them, we end up with just an x, and they combine together to give you your x term of your quadratic. So we've got our x squared terms in the top left to give us our x squared terms in our quadratic. We've got our constant terms in the bottom right, which gives us our constant term in the quadratic, and the other two add up to give the middle term. Now we can use this idea to go the other way. So we know that if we were multiplying out the two factors of a quadratic, we would end up with an x squared term in the top left box, so our x squared term would be here, and we would end up with a constant term in the bottom right hand box. And then we know that these other two terms will both be x terms, and they will add to give the x term. So we can use this when we know what the quadratic is and we're trying to find out the factors. We can fill in the parts of the grid that we know and then use that to try and find out what goes on the outside, so try and find the factors of the quadratic. So let's look at an example to see how it works. So I've got a quadratic equation x squared plus 6x plus 5, and I want to find the two factors, so the two sets of brackets that multiply together to give me that quadratic. Now I know that when I multiply them together, my x squared term is going to end up here, and my 5 term is going to end up here. Because the top left box is the only one where I'm going to have an x times an x, and the bottom right hand box is the only box where I'm going to have a constant times a constant. These two boxes, I don't yet know what goes in them, but I do know that they must add together to give me the 6x. So it's a little bit of trial and error at this point. You need to work out what must go around the outside. Now remember, we are trying to find the factors, so the two things that multiply together to give us this, and this is a multiplication grid. So we need to work out what two things multiply together to give us x squared. Now because it's just one x squared, in this case it's quite easy, it has to be x times x. For the plus 5, we need to think about all the different pairs of numbers that could multiply to give us plus 5, and then test them and see if they work to also give us our 6x. So plus 1 and plus 5 multiply together to give us plus 5, and minus 1 and minus 5 would also give us plus 5. Remember, we are allowed negatives. I'm going to try the positive one first, purely for the fact that my original equation has no negatives in it, so it's unlikely or impossible that there's going to be a negative. So I'm going to try plus 1 and plus 5, and then do the multiplication and check it. So x times plus 1 is 1x, and x times plus 5 is 5x. Now they do add together to give me my 6x, so I know that these two numbers are correct. So I now know that my two factors are the top, which is x plus 1, multiplied by the side, which is x plus 5. And if we multiply that out, to double check, you've got the x times x, which is x squared, which is also in the top left of our grid here, the x times 5, which is 5x, the 1 times x, which is 1x, which are these two boxes in the middle which add to give us our 6x, and then our 1 times 5 multiplies to give us our 5. Now that was a relatively simple example because there was only really one possibility, because you could only have x times x for x squared and 1 times 5 for 5. So let's look at a slightly more tricky example where there could be more than one thing to try. So we start off by filling in what we know, and again the top left is your x squared term and the bottom right is your constant term, and then we know that the middle two terms must add to give us our plus 1x. X, remember, is just 1x. So let's start thinking about what must go around the outside, remembering it is a multiplication grid. So to get the x squared, again, has to be x times x. Now to get the minus 12, there are a few possibilities. We could have 1 times minus 12, or minus 1 times 12, 2 times minus 6, or minus 2 times 6, 3 times minus 4, or minus 3 times 4. So there are actually 6 different possibilities that could work in this case. Now you could try any of these and just try it and see how it works. So if we start with the top left one, the 1 and minus 12, try a plus 1 there and a minus 12 there. Now that minus 12 times plus 1 gives us our minus 12, so we're okay there. But the plus 1 times x would give us a plus 1x, and the minus 12 times x would give us a minus 12x. If we add those together, minus 12 add 1 is minus 11x. So that is not correct. We were looking for 1x and we have minus 11x's. So clearly plus 1 and minus 12 are not the correct numbers. So we need to try 2 other numbers. So I'm going to now try plus 2 and minus 6. So plus 2 and minus 6 gives me plus 2x and minus 6x. They add to give us minus 4x. So again, wrong. Let's try another one. Let's try our 3 and minus 4 then. So plus 3 and minus 4. So plus 3 times x, 3x, minus 4 times x, minus 4x. They add to give us minus 1x. So I can see now that I'm getting close, but I've got a minus where I should have a plus. So if I just switch these signs and use minus 3 instead of plus 3 and plus 4 instead of minus 4, that switches my signs inside, and plus 4x minus 3x is plus 1x. So this is now correct. So I know that my two factors are my top x minus 3 and my side x plus 4. Now you may have started to notice the trick. When we just have a single x squared, we know that it's always going to be x times x. So when we multiply it out, the two numbers don't change in our grid. The minus 3 goes to minus 3x, and the plus 4 gives us plus 4x when we multiply it by the x. So the two numbers must add together to give you the coefficient of the middle term, so how many x's you need. They then need to multiply together to give you your constant term. So there is a quick trick. So if we think about our example from before, x squared plus 6x plus 5, we know that we're going to have an x and an x to get the x squared, and to find out what the two numbers are, we know that they must add to give us our 6 and times to give us our 5. Now some people like to write tax above it to remember which one to add and which one to times. So we need two numbers that add to give 6 and times to give 5. So we know that that's going to be plus 1 and plus 5. Now just remember that trick only works if you have one x squared. If you have any number in front of the x squared term, there is another method that you can do it, or you can use trial and error from the grid. Let's have a look at another example then. So if we have a look at this example, x squared minus 36 plus 5x. Now some of you might start drawing out the grid method, and you might say that the x squared goes in the top left box and the 5x goes in the bottom right box. And then you'll start thinking, hold on, this doesn't look quite right. Remember, it is always our constant term that goes in our bottom right hand box. So our minus 36 goes in our bottom right hand box. That means that you can't just write tax above this equation, because the numbers, the terms, are in a different order to how we've been doing it previously. So the easiest way to do it is to rewrite the quadratic with the highest power of x to begin with, and then write them in order with decreasing powers of x. So x squared plus 5x minus 36. And then our tax term, our tax method does work. So you need to be really careful. If it's written in a different order, you need to rewrite it out in the right order if you are going to be using the tax method, because the numbers need to multiply for the minus 36 for the constant term and add to give you the x term. I would always do that when dealing with quadratics. It just makes life easier. Rewrite it out in the correct order. So if we look at this example, x squared plus 5x minus 36, We could use the grid method, or we could use our new trick of writing tax above to remember that we need two numbers that add to give us 5 and multiply to give us minus 36. Now, if you can't immediately see it, the easiest way is to write out all the things that multiply to give us 36, remembering that because it's minus 36, one's going to be positive and one's going to be negative. So if I've got 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go in, and 6 times 6. Now, we could look at 1 and 36. It doesn't matter which one I make negative, I'm not going to get 5, so that doesn't work. 2 and 18, again, I can't make 5. 3 and 12, I can't make 5. 4 and 9, I know that I've got to make one negative. I clearly don't want to make the 9 negative, because otherwise I'll end up with a negative when I add the two numbers. But if I make the 4 negative, minus 4 add 9 will give me my 5. So I know that I've got my two brackets, each with an x in, and then my first number is going to be minus 4, and my second number is going to be plus 9. Now just a quick check that that works. X times x is x squared, x times 9 is plus 9x, minus 4 times x is minus 4x, and minus 4 times 9 is minus 36. Plus 9 and minus 4 simplify down to 5x, so we have our x squared plus 5x minus 36, which is what we wanted. So our two factors are x minus 4 and x plus 9. Let's just have a quick look at another quadratic that looks slightly different at first glance, but remember, a quadratic is just an expression that has the highest power 2, so we still have that, so this is still a quadratic, but what is missing from this that we've previously had is an x term. So I'm just going to rewrite this as x squared plus 0 lots of x minus 9, so that we can compare it to the previous method. Now if we use our tax method, we know that we need two numbers that are going to add to give us 0, but multiply to give us minus 9. Now because it's minus, we're going to have a positive times a negative, and because they add up to 0, the two numbers have to be the same. Now because 9 is a square number, we know that that's going to be 3 and 3. 3 times 3 is 9, so plus 3 times minus 3 is minus 9, and when you add them up they cancel out. So x plus 3 times x minus 3. Now this is a special example which is actually called the difference of two squares, and it is when you have an x squared minus a square number with no x term, you know that you're going to need the positive square root and the negative square root, so that they cancel each other out when they add, but multiply to give you your number. It's worth pointing out at this point that not all quadratics can factorise. The ones we've looked at so far can, but if, for example, I had x squared plus x plus 3, there are no two numbers that add to give us 1, but times to give us plus 3. They'd either both need to be negative or both need to be positive, so the only possibilities are 3 times 1 or minus 3 times minus 1. Neither of those possibilities are correct to add up to give us our 1x. So this equation, x squared plus x plus 3, does not factorise. Factorising is very useful for solving equations and various other things, but you just need to be aware that it isn't always possible to factorise a quadratic. Now I'm just going to go through two more examples that present slightly different scenarios. So in question 1 over here, the difference is that we have a minus x squared. So instead of being positive, our x squared coefficient is negative. If this was part of an equation that we were trying to solve, I would just move everything to the other side and make it positive to make it easier. But if you ever have to factorise a quadratic with a negative x squared term, it is possible. And I would use our grid method again, because the adding to make minus 2 and multiplying to make plus 3 doesn't quite work because of the minus x squared. So in our top left box we need a minus x squared, and in our bottom right box we need our plus 3, and remember the other two boxes will add to give us our minus 2x. So to get minus x squared, the only way to get that is to have an x multiplied by a minus x. So we need two numbers now that multiply to give us plus 3, but one of those two numbers is actually going to be multiplied by minus x. So two numbers that multiply to give plus 3 could be 1 and 3, or minus 1 and minus 3. I'm going to try 1 and 3 first. So if I put my 1 up here and my 3 on the side, 1 times minus x is minus x, minus 1x, and 3 times x is plus 3x. So if we add those up, we get plus 2x. Now I want minus 2x, so I can see that if I just reverse my signs, it's actually going to work. So instead of 1 and 3, I'm going to have minus 1 and minus 3. Minus 1 times minus x will give me plus x, and x times minus 3 will give me minus 3x, and they now add together to give me my minus 2x. My two brackets then are actually equal to x minus 1 from the top and minus x minus 3 from the side. There were two possibilities because we could reverse the signs of everything, and we could have had minus x plus 1 and x plus 3. That would also work because we've reversed the signs of everything. It would still work out the same. So there are two possible answers if you get a minus x squared in there, but essentially they are the same thing. To do number 2 then, the difference here is that we don't have a constant term on the end. We've looked at it when we don't have an x term because we look for the difference of two squares, but when there is no constant term, it is actually easier because we can straight away see that every term has an x in it. Here we don't need two sets of brackets. If we think about y, if we imagine our grid method, we know that we're going to have 4x squared in the top left box, but in the bottom right box it will be 0. Now two numbers that multiply 0, one of them has to be 0. So one of the brackets isn't going to have a constant in, it is just going to be an x term. But we don't even need to do that. We can just see straight away that 4x squared and minus 20x, we see what we can take out of both terms. We can take out a 4 and we can take out an x. Because there is no constant term without an x in it, we can take out an x of both terms straight away. That would leave us inside the brackets with x, because 4x times x gives us a 4x squared, minus 5, because 4x times minus 5 gives us our minus 20. So if there is no constant term, you actually only need one bracket, and it is a normal factorising, but people tend to forget that. If you had done it using the grid method, you would end up with the same thing. You would have ended up with a 4x plus 0 as one of our brackets, which is just the same as 4x. So you would still get the same answer, but you don't need to. If there is no constant term, you can do it as you would normally factorise an equation. So test yourself and check that you can factorise quadratics when you have a single x squared. Pause the video and I'll give you the answers in a second. So for number 1, if we write text above it, that reminds us that we need to add to get 7 and times to give 12. So we can write out all our factor pairs of 12 and see which ones add up to give 7. So clearly it's not 1 and 12, 2 and 6 would give us 8, 3 and 4 gives us our 7. So we know that our two sets of brackets are going to each have an x in to make the x squared, and then we've got plus 3 and plus 4. So when we times the two constants we get our plus 12, and when we times each number by the x we get 3x and 4x, which add to give our 7x. For number 2, this time they need to add to give us minus 5, but times to give us plus 6. The only way that's going to work is if we have two negative numbers times together, because two negatives would give us a positive when multiplied, but a negative when added. So minus 1 and minus 6, minus 2 and minus 3 are our only possibilities. Minus 1 and minus 6 would give us minus 7, but minus 2 and minus 3 give us our minus 5 that we need. So we know that in our brackets the x times x gives us our x squared, and our two numbers must be minus 2 and minus 3. So now let's see what happens if we have a number in front of the x squared. So this time we have 3x squared rather than just x squared. We can't use the simple add to give 7 and times to give 4, and if we use the grid method we will see why. So we start as we did before with the grid method. We know that the 3x squared goes in the top left and the 4 in the bottom right. and then the other two terms must add together to give us our 7x. So this time, to get 3x squared, we know that we are going to need an x times an x to get the x squared, but that is just 1x squared. The only way to get the 3 is a 1 times a 3. So I've got 1x multiplied by 3x to get my 3x squared. Now we need two numbers that multiply to give us 4, but this time they're not going to add to give us 7 because one of the numbers, the number that I put up here, is going to be multiplied by 3x rather than just x here. So the number will get 3 times bigger. So let's think about our possibilities to get 4. So 1 times 4 or 2 times 2. And of course we could have minus 1 times minus 4 and minus 2 times minus 2. But we know that we have no negatives in our original quadratics, so we will not have any negatives in our factors. So it's either 1 and 4 or 2 and 2. So I'm going to try 1 and 4 to begin with and see what happens. So plus 4 times 3x would give me 12x, and plus 1 times x gives me 1x. 12x plus 1x is 13x, clearly not what we want. So we could try 2 and 2, but before we do that, switch the 1 and 4 round, check it the other way first to make sure that that way doesn't work. So this time I'm going to put my 1 up there and my 4 down here. 1 times 3x is 3x, and 4 times x is 4x. So this time they do add up to give us our 7x. So these are the correct numbers around the outside, which means that our two factors are x plus 1 and 3x plus 4. Now this again was a relatively simple example because there was only one way to get the 3x squared and only a couple of ways to get the 4. If you have higher numbers with more factor pairs, it can become a lot more tricky to find the right pairs of values that work, and it can be a lot more trial and error. There is actually another way you can do it as well. So if you don't like the grid method, I can give you another method. Some people prefer one way, some people prefer the other. So the other method is similar to our tax, but some people call it super tax. So we still need two numbers that add to give us our 17, but this time instead of multiplying to give us 12, because we've got 6x squared, we need to multiply the 6 by the 12 first, which gives us 72, and our two numbers must multiply to give us 72. So instead of finding two numbers that multiply to give 12, we need two numbers that multiply to give us 6 lots of 12, which is 72. So again, you can write out all your factor pairs until you find one that adds to give you 17. 3 times 24 is 72, 4 times 18, 5 doesn't go in, 6 times 12, and 8 times 9 because 7 doesn't go in. But the 8 and the 9 add up to give us our 17, so we know that these are the two numbers that we are looking for. Now these are not the two numbers that go in the bracket, but what they do allow us to do is rewrite out our original equation. So the 6x squared is still 6x squared, but the 17x we can now split into an 8x and 9x. So we split it up into an 8x plus 9x, and then our plus 12 from our original equation up here. So it doesn't matter which way round you write the 8x and 9x, you could have written 9x plus 8x. You will end up with the same answer, but a slightly different route to it. So for the next part of the method, you split the equation in two. So you've got your first two terms and then your second two terms, and you factorise each half of the equation separately, but you must make sure you do it fully. So if we look at the first two terms, the 6x squared plus 8x, we can take out factors of 2 and x, and that leaves us with 3x for the first term plus 4 for the second term. Now if you're not sure on the factorising part, you need to go back and look at a factorising video, make sure you know how to do that. Plus 9x and 12, what can we take out of both of those? 3, and that would leave us with 3x plus 4. So you should notice that both brackets in both half of the equation are the same. If that doesn't happen, you've either got your numbers wrong up here or you haven't factorised fully. So double check it, but that should always happen. Because what this tells us now is that we have 2x lots of our brackets plus 3 more lots of our brackets. So in total we've got 2x plus 3 lots of 3x plus 4. So this is our answer in factorised form, 2x plus 3 times 3x plus 4. So now pause the video and have a go at these two questions. You can pick whichever of the two methods you prefer. I will answer question 1 using the grid method, and I will answer question 2 using the second method. So for question 1, if we draw out our grid, we know that our 6x squared is the top left term and our minus 2 is the bottom right term. Now the 6x squared is going to be x and x, but it could be 1 times 6 or 2 times 3. So it's a bit of luck and a bit of trial and error. So if we try 1 times 6 and then try our two numbers that multiply to give us minus 2, which is 1 and minus 2, or minus 1 and 2. So luckily there aren't too many possibilities here. So let's try plus 1 and minus 2. That would give us 6x minus 2x. So clearly they don't work, because when you add them up you get 4x, not the minus 1x that we're after. Let's try it the other way round with our plus 1 and minus 2. So minus 12x and 1x. Again, it doesn't add up to give us our minus 1x, so we'll have to try again. Now because I didn't get anywhere near, I'm actually going to try changing the 1x and 6x to 2x and 3x this time. We should really try them all, but I have a hunch that that's not going to work. So 2x times 3x gives us our 6x squared, and to get our minus 2, let's try plus 1 and minus 2. So plus 1 times 3x is 3x, minus 2 times 2x is minus 4x. Minus 4x add 3x gives us our minus 1x when you add them together. So our answer is 2x plus 1 and 3x minus 2. Now as you can see, there can be a lot of possibilities to try, but this method will get you there, and the more you use it, the quicker you'll get at recognising which numbers are likely to go where and when to try numbers and when to move on to try the next lot of numbers. However, if you don't like that method, let's have a look at the other method. So this time, 4 times 12 is 48. So we want two numbers that times to give us 48, but add to give us minus 19. So I'm going to start by listing out all of the numbers that multiply together to give us our plus 48. So because they need to add to give us minus 19, I know that they are both going to need to be negative numbers, because two negatives will multiply to give us the positive, but add together to give us a negative answer. So if we start with 1, minus 1 times minus 48 doesn't give us minus 19, so we carry on. Minus 2 and minus 24, again, doesn't add to minus 19. Minus 3 times minus 16. So here we can see straight away that these actually do add to give us our minus 19. We could carry on and list out all the factor pairs of 48, but we don't need to. There won't be another one that adds to give us minus 19, there will only ever be one. So we know that the two numbers that we need are minus 3 and minus 16. So we use the minus 3 and minus 16 to rewrite out our equation, but split up the minus 19x into minus 3x and minus 16x. So we get 4x squared minus 3x minus 16x plus 12. And remember, it doesn't matter if you write the minus 16 and minus 3 the other way round, you should still end up with the same answer. So we split our equation down the middle and factorise each half. So 4x squared and minus 3x, all we can take out of those is an x. So that would leave us with 4x minus 3 inside our brackets. Now this time we have a minus sign between the two halves of the equation. Leave the minus sign outside the bracket, but that means you need to be really careful with what goes inside the bracket. So first of all, think, what can we take out of the 16x and the 12? That would be 4. And if we factorise out minus 4, that will leave us with a plus 4x, because minus 4 times 4x would give us minus 16x. But to get our plus 12, we need a minus 3, because minus 4 times minus 3 is plus 12. So you just need to be really careful. If you've got a minus sign outside the bracket, that will affect the sign that goes inside the bracket. So just be really careful with that. So now we double check, both our brackets are the same. So that means that we have x minus 4 lots of our bracket, which is 4x minus 3. So that is our answer. So in factorised form, 4x squared minus 19x plus 12 is equal to x minus 4 times 4x minus 3. So I hope that makes sense to you. Like I said, the more you do it, the easier it does get. And you can choose either one of these two methods that you like. The left-hand method, the grid method, people find more intuitively easier, but it does require a lot of trial and error. The right-hand method requires a bit of trial and error to find the right two numbers, but ultimately not as much trial and error. So good job, and I'll see you again soon.